So Mr. Rain going over the Precalculus Quiz number 6, 1.1 and 1.4, taken on November 5th, 2018. This is versions P and R. Question 1, determine if the function is even, odd, or neither. You can graph it in your calculator, or algebraically you're going to put in negative x for every x value. Negative x for every x value. Negative x for every x value. Negative x times negative x times negative x times negative x will just become x to the fourth. This will become negative 7x, and this becomes 5, so I have 8x to the fourth minus 7x plus 5. And then we want to look above, and you'll notice that it looks the same. The only difference there is the minus sign. The answer is neither. If you, again, graph this, because I let you use your graphing calculators. So let's bring this up. Let's see if we can have the 8x to the fourth plus 7x plus 5, zoom 6. And you'll see that it's not symmetrical because if you flipped it, it's not exactly the same. So, question number 2, consider the function h as defined. Find the functions f and g so that f of g of x equals h of x. So f of g of x. So g is the innermost part, and h of x is a simple. F and g are the h of x is the complicated one, and f and g are the more simple ones. And if you circle the inside, the argument, you're going to get the g of x. I'm picking g of x because it's the closest one, it's the innermost. So you can also, we talked about how working from right to left on these. So g of x equals 4x plus 2. Well, what do I take all this and put into f? Well, f has to be the absolute value of x, because you're kind of putting all of this in here for a value of x. It's not this one because you don't have the negative sign. Over here, if you did choose f of x to be x, this one would have to be the absolute value, but it's not, so I would not pick that one because you would put all of this into here. This one has the negative sign there, so it's not this one. Our answer is C. You know how to match this. Alright, 3, match the graph by writing the appropriate basic function in the first blank. So it's name, and then the equation and function in the second blank, 1 point apiece. So here we have the natural logarithmic function, and this is y equals ln x. Number 2 here, you have a quadratic function. This one is y equals x squared. Let's just say graph 3. Here, this one is starting up here at 1. When it starts at 1 and ends at 1, this one is the cosine function. So this would be y equals cosine x. That's the abbreviation for it. And the last one is the logistic function. Logistic function. And this one is written y equals 1 in the numerator, and the denominator is 1 plus e to the negative x. Use the graphs provided in question number 3 above. This one should be 4. That's your which of the graphs are bounded? So we're looking for something that's here. You might think this one's bounded above, but bounded here means both above and below. So below, above, and below, above and below. Your answers are 3 and 4. Which of the graphs has even symmetry? So can you fold it? Remember, my trick word is evenly folded on the y-axis. So that would be graphs 2. This one cannot be folded. Cosine can be. Use your, show it to you guys, Premiere. And you see that the graph's kind of repeating exactly. So graph 3, graph 4 would not. Alright, on the back side here, I have f of x and g of x, and the back side of your response, make sure you show all your work and box your answers. So, find the following along with their domain. So, the domain, remember you're going from left to right, and here you have a linear function. So the first thing I touch is an arrow on the x-axis from the negative infinity to positive infinity. So you can, domain here is negative infinity to a positive infinity. Remember, the trick is if you see two arrows, then it's going to be this. X cubed, your graph looks like this, two arrows, same thing. Question number 1 says function of f plus a function of g. So f of x equals 2x minus 5. And you're going to basically add 2x minus 5 plus the function of g. So this would be x to the third. So you'll notice that there are no like terms here. So I can just put that in descending order, x to the third plus 2x minus 5 with a domain from negative infinity to positive infinity. And this will be our answer. Question 1b tells us to subtract the function, so f of x minus g of x. F of x is 2x minus 5 minus g of x, which is x to the third. I'll take the inverse of that, so that becomes negative x to the third plus 2x minus 5 with a domain of negative infinity to positive infinity. Question number 6c tells you to multiply because there's no math operation between them. So I have 2x minus 5 times x to the third, and you're going to kind of do this backwards distributing here. So that becomes 2x to the fourth minus 5x to the third, and then with the domain negative infinity to positive infinity. So basically in the function of f, you can pick any values, and function of g, you can pick any values. So when you're doing some adding, subtracting, multiplying, dividing, you pretty much can pick any of the numbers, except when you do division. So let's do division. F of x divided by g of x, so that gives us 2x minus 5 over x to the third. Now don't do anything crazy like canceling there, that would be incorrect. Now our domain here, we can find algebraically of our rational function here by setting it not equal to 0. Well, finding the cube root, any three identical numbers that multiply by 0, x cannot equal 0. So when we're writing our domain, it's our f divided by g is 2x minus 5 over x to the third with a domain of negative infinity to comma 0 union with 0 comma infinity. Basically that's just a fancy way of saying you can pick any value except for 0. So answer. Let's move on to question number 7. Here I have a piecewise function, 2x plus 1, and with a boundary at 1. This is not an asymptote, this is not a vertical line, it's just a boundary, helps us visualize. The first function of 2x plus 1, I have a y-intercept of 1, and I have a slope of 2, or 2 over 1. So that means rise 2, up 1, rise 2, up 1. Now the restriction in the domain tells us bigger numbers that are bigger than or equal to 1. So equals to, okay, bigger than 1 on the x-axis would go to the right side. So my graph's going to look something like that. Okay? And if you ever get stuck, you can always just make a table of values, right? And then go through on your calculator and just get a couple of values. You want them on the positive side of 1. 2x plus 1. And then you're going to go to second table set. Make sure those are on auto and auto. And go second graph. And you have all these values, and you want numbers bigger than 1. So 1 is 3. 2 is 5. And 3 is 7. So you can just go here and actually just graph those order pairs. Y equals x squared plus 3. And here I want values that are less than 1. And so I'm going to the left of that. So let's choose values that are smaller than that. You can choose 0, -1, -2, -3. Let's also choose 1. I know it tells us not to include 1, but I need a value there. So I'm just going to put this into my calculator. X squared plus 3. Go back to my table. Copy down some numbers. If you didn't know how to graph that. 1 is 4. 0 is 3. -1 is 4, 7, and 12. So 1, 4, right above it, open circle because of that. Then I go to 0, 3, -1, 4, -2, 7, so 4, 5, 6, 7, something like, graph's going to look something like this, okay? And those should not be touching. I probably would have given you like 3 points if you can graph one of those, and 4 points total if you can graph both of those. Question number 8, graph the function. Make sure to include asymptotes and a table of values. So I have function g of x equals 1 over x squared, so I'm going to get my x-intercept, which means make y equal to 0. In this problem, there is no y value, so you make this one the y. And we're going to make that 0. To make 0 fraction, I'm going to put over 1, so now I'm going to cross multiply. 0 times x squared is 0. 1 times 1 is 1. Can 0 equal 1? No. So when I say no solution, that means there is no x-intercept. The graph's actually not going to touch the x-axis. Y-intercept will make x equal 0. So same equation, y equals 1 over x squared. I'm now making every value 0. 0 squared is 0. 1 divided by 0 is undefined. So basically we're not going to have it touching the y-axis either. Let's get some vertical asymptotes. Then on the back side, the vertical asymptotes, you're setting the denominator x squared not equal to 0. Take the square root. Two identical numbers that multiply by 0 are 0, so x cannot equal 0. So that'll be our vertical asymptote. Then the horizontal asymptote, we're going to compare the highest degree. So here, this one is like x to the 0. And then the next highest degree is 2 here. So think about what inequality you can put there. Well, the inequality you can put there is that 0 is less than 2. Okay? Well, what does that tell us? it tells us, let's see if I can find my chart here, and I can show you. Don't have it in this one. Alright, sorry that took so long. If your numerator is smaller than your denominator, I mean your denominator is bigger, then just like we have here, we're going to have to, you always have y equals 0 as your horizontal asymptote. So again, just compare the highest degrees, and you get this chart here. Okay. All right, let's graph it, and then we can look at a table of values. So here is y equals 0. And the vertical asymptote tells you at x equals 0 how, remember it's vertical up and down, that one's horizontal side to side. This will kind of show you how many parts and kind of where to graph your table of values. So my table of values is an x and y, and I'm not going to pick 0, so you can just pick -3, -2, -1, 0, because I know this part is going to be undefined here, and then 1, 2, 3. Let's put that in our calculator. And really what the calculator is doing when I show you the table of values, you're just putting in -3 into x here, and then it'll give you a value such as 1/9, and then it's just going to give it to a decimal form. So whoops, 1 divided by x squared. So -0.33 is going to be a positive 2.5, -1 is 1. 0 undefined there is our vertical, and then 1 is going to be a 1.25. Okay, so let's kind of graph this. I recommend using a pencil. So -3, 1, 2, 3, and just that 0.1. Just notice what's happening to the values here. They're getting bigger and then bigger. So the graph's probably going to look something like this. Undefined, and then at 1, 1, less, going smaller and smaller. So then your graph's going to look like this. Okay. And that was out of 24 points. That one was 18. These are 1 point apiece, so that gives you the 42. Good luck.
I love math. You don't love math? What's wrong with you?